good morning, everybody. I'm Storm Ushry, Conservation Education Manager, and today we've got a special guest who's going to be joining us this morning. Our guest this morning is going to be Sean Denny. He is our warm water sport fish supervisor, and he's going to be giving us a presentation or one of our fisheries presentations this morning. And Sean, go ahead and take it away, sir.
Hello, my name is Sean. Like Storm said, I'm a warm water team supervisor for sport fish in New Mexico. I started with the department in 1993 as a co-op student, summer intern student. I started full-time in 1997 as a conservation officer. I was a district officer in Las Cruces for 3 years. And then I moved into what we called an area fish manager in those days. So I worked in Albuquerque in the Northwest area for a year, but most of my career has been spent here in Roswell as a Southeast area fisheries manager. So I did everything that concerned fish in the Southeast area, from endangered species all the way up to working with trout in the mountains and also fish in the reservoirs. Warm water fish has always been more of my interest. So as the department changed and was reorganized, I became a warm water fisheries biologist. Most of my area of responsibility has been with catfish and catfish management, particularly in evaluating and trying to streamline our channel catfish stocking programs. But I work with all of the warm water fish around the state at various times. So today, we're going to talk a little bit about what we do with fisheries data as a fisheries manager. So oftentimes we see people that are managers and we do research in order to fix a problem, right? Versus pure research where somebody at a university might just be trying to answer a question. Their goal is often to gain knowledge and move to the next question. Our goal when we do research, when we go out and study these fish, is we are trying to check conditions to conserve these fish, to make conditions better for anglers. We're trying to solve a problem in most cases. So with that, we'll go ahead and jump into my presentation. We're going to talk a little bit today about fisheries data and how we interpret it. So I'm going to keep this really simple. Fisheries data can get very complex with computer models and crazy statistics and equations. And so, but we're not going to talk about that part because I don't want everybody's eyes to glaze over. But just know that I'm going to very much simplify the basic things that we look at. A lot of the work that I do is funded by not just licensed anglers and sales, but by the Sport Fish and Wildlife Restoration Act. So when you go buy a piece of fishing gear, there's an excise tax on that gear. That money goes to the federal government, which then disperses it back out to the states. So a lot of my work is funded by that stream. So why do we manage fish? Why do we care? So fish are around the world, right? Most of the time we think about our local environment and where those fish are. But one of the main reasons to manage fish is because we eat them. Fish is the #1 source of protein around the world. We don't think of that a lot living in the desert Southwest, but I'm sure that most of you have eaten fish at some point in the last month or so, whether those fish were fish you caught or fish you purchased in the store. So some of the things that we're going to talk about today apply from a tuna fishery in the ocean all the way down to a freshwater fishery that might be in Central or South America or in Asia. So just remember that fish are a very important source of protein around the world. We catch fish. This is the end of the business that I'm most interested in and that I deal with the most. It's a multi-million-dollar industry around New Mexico, multi-billion-dollar industry around the world. So not only do people try to catch fish as a food source, but people try to catch fish as a way to connect with their environment, as a way to relax. It's a very important social aspect in many communities. And so keeping anglers happy is important to me. Preserving fisheries for future generations is very important to me and to the department, as well as providing fish for people to eat. So this is the main emphasis that I have. People watch fish. Um, I, I'm a scuba instructor. People travel all over the world to go scuba diving. And essentially, when you go off somewhere to go scuba dive, you are fish watching. Just like somebody watches birds in their backyard, people go other places to watch fish. So if this fishery crashes on this reef, right, that entire industry and people won't come there anymore. And so it's important that that fishery is managed as well. So what do we need to know to manage a fishery? Really, it's important to know what kind of fish are there, right? The things that we do maybe are different, and our options are different to control a tuna fishery in the ocean versus controlling a rainbow trout fishery or managing a catfish fishery. So we need to know what kind of fish are there. That oftentimes does not just include the fish that we're interested in, but includes the other fish in that community. We need to know how many fish are there, right? And so we're going to talk a little bit about this in some future slides because this can be somewhat misleading when I say how many, but we're going to talk about that a little bit further down the line. How big are the fish? Now, this is important because anglers always want more bigger fish to catch, right? But how big those fish are can also dictate how much you get to eat sometimes. If you're in another country or in another place where you're dependent on fish to sustain yourself. And then we need to know how healthy the fish are. So this does not mean not only are these fish free of disease, but overall, are they getting enough to eat? Are they growing fast enough? So in broad, now each of these categories has lots of little things that we look at from time to time. But overall, these are the four main categories that we watch. So in order to assess a fishery, in order to learn about what's going on there, we have to collect these fish. We have to get our hands on them to see what's going on. Oftentimes in wildlife management and other forms of biology, people just go out and look, right? You probably all know about Jane Goodall that studied the apes, right? Where she just embedded herself and she watched and learned about those animals. When we do elk surveys, they fly over the elk herd and they count those animals. Well, because these fish live in a different environment than us, being in the water, it's pretty difficult to do that. So we actually need to catch these fish. There's going to be other modules that have more information about these specific fish collection techniques that you may have already seen or that you're going to be able to see in the future. But just in general, we have different techniques. So if you look in the upper left, we're using a backpack electrofisher. It puts an electric charge into the water and it stuns the fish, and then we net them up. The top right is what we do in the reservoirs mostly, and that's using a boat-mounted electrofisher, so it puts out a lot more electricity. It stuns the fish. The person on the front of the boat nets them up. We collect our information, and then we put the fish back in the water. And we also use various forms of nets. A gill net, which is basically just a big panel that fish can get entangled in. And we also use a fight net or a hoop net that's basically a big trap. Fish swim into it. They're not entangled. They just don't know how to get out, and then we can come collect them. So you're going to get more information about that in other modules. What I'm going to talk about is more what we do with these fish once we get our hands on them. So processing. Once we get our hands on these fish, we're taking that fish out of its environment. What we want to do is learn about these entire fish populations. So we tend to do things very quickly. So, for instance, if we catch a blue cat like this one that came from Elephant Butte, that fish is old. That fish is valuable to an angler, so therefore that fish is valuable to us. So we do the best we can to minimally impact these fish. Now, that does not mean that sometimes we do not kill fish in order to gain more knowledge that helps us protect the population. Um, so, but most of the time, we're working really quick, trying to keep these fish out of the water for as short a time as possible. The essence of fisheries management are lengths and weights. So, once we get our hands on a fish, we identify it, we get how long that fish is, and then we get how much that fish weighs. Those pieces of data, right? We know how many fish we caught, we know how long they are, and we know how much they weigh. And then most of the time, we have a general observation of their health. Sometimes we do more in-depth disease type evaluations, but whether you're working with salmon in a commercial fishery in the ocean, or you're working with rainbow trout, the length and the weight of fish is the essence of what we work with. So we talked that we need to know how many fish are there. The way we go out and sample fish, so for example, at Sumner Lake, we would take our electrofishing boat, we would electrofish down the shoreline for 10 minutes. We process all of those fish, then we move to another portion of the lake and we work for 10 minutes. Then we move to another portion of the lake and we work for 10 minutes. We do not shock every inch of the lake. And what this does, it gives us an indication of what we call catch per unit effort. So in the case of electrofishing, we use fish per hour. So at one site, maybe we caught 5 fish in 10 minutes. At one site, maybe we caught 25 fish in 10 minutes. We take multiple sites from a lake, we average those together, and it gives us an indication of fish per hour of our catch rates. So the important aspect to that is we don't know how many fish are in the lake, right? We don't know if there's 500 or 5 million. But we do know when we look at this information over time, if a fish population is getting larger or if a fish population is getting smaller. So in this instance, the blue line is for spotted bass. And you can see from 2015 to 2020, that line, it has some variation, but it tends to be moving upward, right? When you look at the orange line for largemouth bass, that line tends to be moving downward. So this is an indication to us that the spotted bass are probably doing well. Their population is tending to increase. The largemouth bass are probably not doing as well for probably a multitude of reasons, but that population is decreasing. So depending on the severity of these changes, the desire of our anglers, what we think the potential of a water body is, we may change our management based on this type of information. So when we talk about how many fish, we're often talking about trends over time and how we look at the total, the catch rates of those fish. So I talked about how big fish are. So most of the time we take fish and we break them into length categories. So if the entire time at Sumner Lake, we caught 100 largemouth bass over the entire survey. All of those largemouth bass, we have how long those fish are. We take the length of those fish and we put them on what we call a length frequency histogram. So really, when fish are born, right, there's a lot of them. Fish have a lot of eggs, so there's a lot of fry. So that's when you'll have the biggest number of fish, right? And then as that year class of fish moves through their lifespan, fish die. Maybe people caught them and ate them. Maybe a bigger fish ate them. And so those numbers go down. So if you look on the top right, you'll see that the most fish we had is in this column, right? In reality, this would go up in most cases, but because of how we collect these fish, we just don't catch these small ones. So think of this as a curve that comes all the way down and works its way over, right? So this is a somewhat natural looking curve. Most of the fish, when we can start collecting them, are here. And then as our fish get older, they get to be fewer big fish in the population. This is a natural progression of what happens, right? But we can also see things happen. For instance, if you look at the top left on the graph labeled 2001, we have our block of fish where most of the fish are from 7 to 10 inches, right? We have a few bigger ones, but most of them are in the 7 to 10 inch range. The next year, we see that most of the fish we captured are 10 to 13. This is good, right? There's more big fish in the population. These fish all got larger. Well, not necessarily. If we were getting normal recruitment and those fish are having the same number of babies every year, this graph should not have moved, right? Because there would be smaller fish coming in to replace them. What we see here with this shift gives us concern because there's not smaller fish coming in to replace these fish. So as these fish move to the right and they become fewer and fewer, if we do not have young fish coming in to replace them, we could see the population crash, right? So oftentimes in the oceans, when they lose their reproduction, this is kind of the trend that you see. We see this to some extent in our reservoirs because we have a lot of variable recruitment from one year to the next. But more bigger fish in the population is not always good for the long term on the population. So we talked about how healthy the fish are. The main thing that we look at on that is whether a fish is fat or whether a fish is skinny. When we take a length and we take a weight, we are able to use some mathematical equations to calculate what we call a relative weight. So every species of fish has a different equation because a 6-inch channel catfish does not weigh the same as a 6-inch bluegill. Their length to weight ratios do not change over their lifetime the same. So we have different equations for different fish, but they all come back to the same place. So essentially, I guess I'll call it a perfect fish, but that's not necessarily the right thing, is 100. So just like you have a body condition index that you probably had calculated, whether it was at school or whether you went to the doctor, right? They took your height and they took your weight and they gave you a body condition index. That's the same thing that we're doing with these fish. So if we have a lot of fish that are really fat and really healthy, that means there's plenty of forage for those fish. They should be growing well. We might have some options to work on that fishery. If we see fish that are long and skinny and essentially are malnourished, we don't have as many options, right? Or we have different techniques to try and address that. Certainly stocking more fish, if there's not enough food there for the fish that you have, would not be smart, right? But this really helps us answer the questions of how a population is doing. So the WR is what we call relative weight, and there's a bunch of jargon on this graph, but remember we talked about fish up close to 100 as being good. So the first two columns here are Sumner Lake. The MIPU are spotted bass. The MISA are largemouth bass. Yes, fish guys are kind of nerds, so we have all kinds of jargon that we talk back and forth to everybody with. So don't let that confuse you. These spotted bass are up close to 100. That means that population of fish is doing well, right? They're getting enough to eat. They're plump. The largemouth bass are not doing as well, right? They're a little bit skinnier, so they're not getting as much food to eat. Do you remember the graph that we looked at before where the spotted bass were going, their population was trending up, and then the largemouth bass population was trending down? This could be an indicator that forage is part of what's driving that change in that population, right? Because the largemouth obviously are not getting as much to eat as the spotted bass. So most of the time, there's not a smoking gun when we're looking at these different management type scenarios or when we're monitoring these fish, but you have to take a little bit of evidence from everywhere else, and sometimes you even have to do a more in-depth type of study to answer questions. So let's look at an example here. If I go to a small pond, say Lake Roberts, or could even be Lake Van here in Roswell, we go out, we electrofish, and we average 55 fish per hour as far as largemouth go. We average 55 largemouth. So every hour of us putting electricity in the water, we average 55 largemouth. This is a fairly high number. I don't expect you guys to know that, but just so you know, our goals are 20 to 40 fish per hour in most of our recreational fisheries for largemouth. So 55 is a high number. Well, man, that's good, right? I want to go fish there because there's lots of bass and I like to catch bass. Well, but when we look at this center graph with our length frequency for these largemouth, all the fish are from 7 to 10 inches. We can't even keep any of these fish to eat because the statewide length limit is 14 inches. So what is the problem here? Some anglers will say, oh, it's because they come in and they catch all the fish, they never have a chance to grow, and so there's no big fish in the lake. Well, we know that there's no big fish in the lake from our surveys, but when we look at the relative weight is down at 77. These fish are long and skinny, right? So what this tells us, there are a high number of fish in a water body. They are not growing because they're not getting very big. So they're skinny. So that's typically what folks call a stunted population. It tends to happen with largemouth bass in a small pond, and oftentimes it can happen with sunfish in small ponds. The reproduction outruns your resources for those fish to eat. So what could we do to remedy this situation? Stocking more bass obviously is not a good idea, right? There's not enough there for these guys to eat. If it's a small pond and maybe a private landowner, he may buy forage fish to feed these fish. But in most cases, what you have to do are remove some of these fish from the population so that other fish have more to eat. Does that make sense? So we had too many fish, essentially. There is not enough food for them to eat and to grow to get into that size that we want to see. So we remove some of these fish. And we'll talk about some of the tools that we have within the Game and Fish Department later. So here's another example where we use essentially the same thing, but we're looking at a different species. So with walleye, we use gill nets. We set these nets out. Walleye swim by at night, then we come back and get them the next morning. 8 fish per set night is another high density. Our goal for walleye is 4 fish per set night. So we may set out 15 nets in a night, and we want to average at least 4 fish per net. So 8, that means this is a good walleye population. There are lots of walleye here. When we look at our length categories, right, we see this number of fish. These small fish, the small walleye, they just don't get caught in our nets. That's why you don't see them. But when you look at this big number, that's when those fish are what we call fully recruited. So we think that we're catching a the correct percentages of that population, and then it just drops off, right? Boom, drops off to nothing. There's a few big fish, but not many. So what could be driving this? So these fish are getting to 12 inches, and then there's just a ton of them that are gone, right? We're dropping off to just a few large fish. Well, the fish, they have a relative weight of 108, so they're fat, right? There's plenty of food there for them to eat, so they should be growing well and becoming adults. This is common that we see in fisheries that are not really highly catch and release, in fisheries where folks eat most of the fish that they catch. So what we're seeing here in this center graph is once these fish are big enough, they're being removed from the population because people are taking them home to eat. So a lot of anglers may be disappointed because they would like to catch a bigger fish and there's just not as many of those there. So, but essentially what we're doing is we are on the verge of over harvesting this population. So let's say that something like COVID hits, more people go fishing, more people are trying to catch fish, and so the pressure increases and we remove some more of these larger fish. Now we do not have any fish to spawn. This whole population can crash because fish are not getting big enough to spawn, right? So in this situation, we may apply a length limit to fish. And because of data like this is one of the reasons that walleye, sometimes we put a 14-inch limit on. That way, when a fish, this line essentially, even if we have the same harvest, will move over closer to 14 inches. That means that one, we can get a year of reproduction out of that fish before it's harvested. Two, that angler gets to take home more meat because he caught a bigger fish. The same thing happens in the ocean. When you overexploit a population and you catch too many of these big fish, there's not enough to reproduce, and you can eventually end up with a population crashing. So whether you're looking at fish in the ocean or fish here, these are the kind of indications that we look for. Now then, there's a lot more complicated mathematics that go in. There's other factors that we looked at. But in general, we're looking at how many fish we catch, which is a good number. We're looking at what the population size structure is, and we're looking at the condition of those fish. So what now? We identified some problems with those fish. What are the tools that we have as fisheries managers to go out and fix those problems? So stocking is typically the number one thing that people think of. Most of the time that's the general public, their automatic cure for everything is to stock more fish. And in some waters that very much can help. It's not always the fish they want. For example, where we talked about the largemouth, we may have wanted to stock forage fish there. We certainly wouldn't want to stock more largemouth. But our programs in New Mexico, we have a lot of small waters that get a lot of pressure. So we stock a catchable fish. So we stock a lot of rainbows that are in that 10 to 12 inch range that are ready for people to catch and take home and eat. Because the system, that pond or that stretch of river, cannot produce enough fish for the amount of people that go there to fish. Sometimes we make legal changes. We have legal regulations within the state. We may change a bag limit on fish. We may change a length limit on fish. Most of the time, those things are done in order to manipulate a certain species to make it better for anglers or to protect that species because we do not want to see that population crash. Sometimes we make habitat adjustments. So for example, in that earlier population that we talked about of the largemouth that were too skinny, we might add some habitat into that lake, not for the largemouth to use, but for bait fish to use so we get more bait fish production and those fish have more to eat so they can grow better. Sometimes we make adjustments within a stream so that there is more holding habitat for trout to use, or there is more production and shade so those trout have cooler water, better bug production so they can grow and live better. So once again, my name is Sean Denny. Here's my email on and access to our Game and Fish website. There's some information about current projects on the website, some information about how we manage certain species. My email is on here. If you have more questions about how we look at this data or more technical questions, you are more than welcome to give me a call and contact me through the email is the best bet. Be happy to visit with you and try to give you some more information.
I just want to thank you, Sean. That was very, very interesting. I know some of that information that you gave, some of it kind of rang home to some of the fisheries classes that I did take in college, and it's one of those to hear that again. It kind of puts a lot of stuff in perspective for me, and I just want to thank you for your time today. And before we end today, do you have any neat little story that either something with the job or anything that you would like to share with people? It could be an interesting story, words of encouragement, if somebody's interested in being a fisheries biologist, anything along those lines, that would be great.
Well, I guess there'd be a couple of things. I always liked to fish, and I was always the fish guy, right? And so I started out through my college career and when I was looking at places to go work, I wanted to go mess with fish, right? One of the first things you learn when you come to work with New Mexico Game and Fish is you can't just go work with the fish. You also have to work with people. People are an important component of what we work on and what we do within Game and Fish. So the thought of hanging out on the lake every day and being able to look at those fish is not exactly the way it goes. We spend a lot of time talking to anglers and working with the public. But one of the main things is I want to stress especially within the sport fish program and my team. Let me pull this back up on the screen. So this young man's name is Gabe, and I met Gabe through various sources, and we'd been on an antelope hunt. I took him out, and we killed an antelope early in the hunt. And he said, "Well, I want to stay and fish. I don't want to go home." So we stayed at Clayton Lake. Clayton Lake, the catfish fishery, had essentially crashed. One of my projects has been returning some catfish to Clayton Lake, and I complained about it from the beginning because it takes me almost 6.5 hours to drive to Clayton Lake every time I need to do a field collection or I need to do any work. But I was doing a survival study on stock channel catfish there. So Gabe went down to fish, and I went on and was setting up camp, doing some stuff, came back, and he had these two catfish. You can kind of see it on this photo, but you can't see it on this fish. These are two different year classes of fish I stocked. Every one of these fish was handled by someone at New Mexico Department of Game and Fish when they were about 5 inches long. They're freeze branded across their belly so we could identify them as a stocked fish. But here is where everything came back together for me, because the work I did with the liquid nitrogen and standing there getting my hands stabbed trying to brand all of these fish, the driving back and forth to Clayton Lake to complete the study, all came home because he was able to actually come and catch some of those fish. This is the goal for us within the sport fish program. We want people to catch fish, and we want people to be happy. But this is one of those stories that definitely that comes around and really helped rejuvenate me. After you've been doing this for a long time, it's really easy to get jaded and kind of lose your momentum. This project really helped me, and him catching some of those fish really helped me learn and move on from that.
Well, awesome. That's a very good story. And I know one little one I was going to share. We talked briefly about it before we started today, but I met Sean actually in 1997. I believe you would have been, were you the Las Cruces district officer at that time, Sean, or?
Yes.
Yeah.
Yeah, by the time hunting seasons for 1997, I was a district officer in Las Cruces.
Yeah, because I had an oryx hunt on the small missile range, and that's where I got to meet Sean. And that was many years ago. I don't think that he remembers that interaction, but I do. And he had such a positive impact on me, and he was just a joy to be around. It was just a lot of fun. But, anyways, with that, we'll go ahead and end today's recording. Do you have anything else you needed to add, Sean, or you feel good with everything?
I don't think so. I think that kind of covers it.
Okay, cool. Well, we hope you all enjoyed today's presentation. I know I enjoyed it. I learned quite a bit, and we hope that you enjoy the other videos that are going to be coming out as well. And with that, I just want to wish everybody a happy day, and we're going to end today's recording.